Find the number of ways in which the letters of the word elevated can be arranged if there are no restrictions. So number one, you can count the number of letters in the word. So ELE, you can see that the number of ways no restriction. We can see that first there are how many letters are there? There are actually total of 8 letters. So for the letter E, right, you have a total of 3 letters. For the letter L, there's 1. For the letter V, there's 1. For the letter A, 1 as well. For the letter T, 1. For the letter D, also 1. So total of 8 letters. How many ways can we arrange them? So you know that there are 8 letters, in which 3 are identical. So the answer will just be, for part 1, will be equals to a factorial divided by one group of identical objects, which is 3 factorial, and the answer is 6720 ways. Right. Part 2, T and D must not be next to one another. So actually there are a lot of ways to do this. Number 1, you can either use a slotting method. That is, if we say that T and D must not be next to one another. So one way is we can say that we just consider that there are 8 letters left. Okay, so maybe T and D. So you take out T and D, you have 1, 2, 3, 4, 5, 6, right? So a total of 6 letters. And then since T and D cannot be next to each other, so it can be here, either of the red arrows. It can be either of the red arrows, right? They can slot into any of the red arrows. So out of these 6, right? 1, 2, 3, 4, 5, 6, 7. Out of these 6, we can take 2. And then remember that 1, 2, 3, 4, sorry, 7. Out of the 7 slots, we are taking 2 slots. So actually it's just 7 permute 2, right? Because 7 permute 2, because T and D take 2 slots to enter out of the 7. Okay. Then among the blue color slots where the boys are, okay, sorry, not the boys, the elevated, the other 6 remaining letters, they can permute themselves in this side, because in the remaining letters there are, you remember that there are 3 E's, 1 L, 1 V, 1 A. So the number of ways to arrange this, I purposely use a different color for the different, is 6 factorial over 3 factorial, because there are 3 E's, so we need to account for this. Alright, above all, you should notice that if I slot in, say, TD here, right, TD, right, it can be TD, it can also be DT. So you have a total of 2 ways, or 2 factorial ways. So my final answer would be 6 factorial over 3 factorial multiplied by 7 permute 2. Alright, or you can say 7 choose 2 times 2 factorial multiplied. Okay, that would be all. Oh, sorry, don't have 7 permute 2. Just that. Okay, why? Because the permutation already took into account the arrangement. Okay, so they will just be 5040 ways. Another way to look at this is that if, for example, if we want to find the number of ways in which T and D are not together, we can find the total number of ways such that minus the total number of ways that T and D together. So a second way to doing this is to take the total number of ways, right, minus the number of ways. This is what we call the complementary method, and D are together, right? So this is method 2. This is method 2. Okay, so I want to find the total number of ways in which T and D are not together. I can take the total number of ways minus the number of ways in which T and D together. So total number of ways actually is just from part 1. The answer is 6720. Alright, and if I want T and D together, so basically what I do is I consider T and D as 1 unit. Alright, so if you go to the side, it's like T and D are 1 unit. Then you have 3 E's, we have L, we have E and A. So I'm looking at 1, 2, 3, 4, 5, 6, 7 units. Arranging 7 units, out of which these 3, they are the same. Alright, so we divide by 3 factorial, and also you can have TD as well as DT. Alright, because you can have TD, you also can have DT. So there are 2 ways, so we need times 2. And with that, right, the final answer will be 5040 ways. Right, then this would be for part 2. Alright, let's go back to part 3. And the consonants and the vowels must alternate. So the consonants, let's look at it as though maybe we look at this is an alternate problem, an alternating problem. So consonants could be that the consonants are taking or the odd number places, the vowels are taking these places, right? So with that, okay, let's take a look at the vowels. Maybe the vowels we have, what do we have? The vowels we have E and A, right? E and A. So there's actually 3 E's and 1 A. So suppose we take all these vowels, right? We have a total of 3 E's and 1 A. And the number of ways to actually slot in these 3 V's and 1 A's, you can see that we have a total of 4 vowels. So it's 4 factorial ways to arrange them, divided by 3 factorial because you have 3 E's. Alright, and if I look at the red color portions, I have LTVA, right? How do I arrange the consonants? LTVA, there are 4 different letters, so the ways to slot them in is just 4 factorial. Above that, you also know that this is not the only arrangement, right? So besides starting with the consonants, I can also start with the vowels. So another way I can do this also, I can say, I can put my C's in the second position. I can start off with the V first, right? So this is also another way. And then you can see it here, there are a total of 2 ways. So besides starting with the C consonant, I can also start with the vowel. And with that, my total answer, okay, we're considering 1, 2, 3, right? So it just be 2 ways times 4 factorial times 4 factorial over 3 factorial ways, and the answer comes out to be 192. Right, so basically I use different colors for the different considerations, so I hope that you think about it. 4 factorial because there are 4 factorial ways to arrange the vowels. There are 4 factorial over 3 factorial ways to arrange the consonants, right? Sorry, 4 factorial ways to arrange the consonants, 4 factorial over 3 factorial ways to arrange the vowels, and 2 ways because we can start with V first or we can start with C first, right? Last but not least, we have question 4, part 4. Between any 2 E's, there must be at least 2 other letters. So this is actually quite a tough question. Now we need to think about what are possible scenarios. So we actually need to consider cases, right? So we have a total of 3 E's. We need to actually consider the cases. So we have 3 E's, right? Between any 2 E's, there are at least 2 letters. So if we consider 1, 2, 3, 4, there are a total of 8 letters. One possible pairing could be E, and then another E here, and then 2 spacings and another E, right? Also, what's another pairing? So actually you can actually work out the total number of cases. And this is one pairing. Another way is I can put 1 E here and at least 2, right? So I can skip 3. I put 1 and I put 1 in the last one, right? So this is also one possibility. Third possibility could be me not even starting with the first letter E. I can put it the second letter. I skip 2 spacing, I put the second letter, and finally third letter. For any more, right? And one more possibility is instead of I can also do this E, 4, 5, 6, 7, 8. And what else can I do? I can actually still skip 2 and then skip 3. Possible, right? So this one is I skip 3 and then I skip 2. This one I skip 1, I skip 3, 2, and then I skip 2. This one, you look at the number of spaces, 2, 2, 1. I skip the number of spaces is like 2, 3. So basically the different kind of possibilities for me to arrange the E such that there's at least 2 letters between them. And what am I left with? I'm left with the letters L, T, V, and A. Am I right? I'm left with the letters L, T, V, and A. L, T, V, A, D. Sorry, I have 5 letters. How many ways can I slot them in? You can see that for each case, the number of ways to slot them in, there are a total of 5 slots. Right, so for each case, the number of ways to arrange them is 5 factorial. Similarly for the second case, 5 factorial. The third case, 1, 2, 3, 4, 5. 5 factorial. Also for the last case is 5 factorial. So the answer for just part 4 would be to consider all 4 cases, and for each case, right, after I fix the E, the number of ways to arrange the other letters is just 5 factorial. So simply we have 4 cases multiplied by 5 factorial, and the answer just comes out to be 480. And that's the end of question 3.